Good morning, students in periods 1, 5, and 6. This is Monday, January 25th. These are the notes for the adding and subtracting in scientific notation. You should have a guided notes page that the sub gave you that you need to fill out as you are watching these examples. And I will tell you what to write down, and I'll tell you when to stop the video. You will be turning these guided notes in tomorrow, so make sure you watch the entire video and you complete the notes before going on to the homework. All right, you will notice at the top of your guided notes there are two special notes that I wrote down. Number one says, before adding and subtracting in scientific notation, exponents must be the same. And number two, remember to always change the exponent to the highest exponent. If you do this every time, then the procedure is very simple. So in problem number one, and remember you need to be writing down what I am doing right here on the iPad, you have 4.25 times 10 to the third plus 6.14 times 10 to the fifth. So because we have different exponents, we need to go to the highest exponent. So we need to change this 10 to the third to 10 to the fifth. And if I go from 10 to the third to 10 to the fifth, that is, I need to add 2. Well, when you go to the highest power, the good news is you always move the decimal the same direction in your number. So to go to 10 to the fifth, I need to move my decimal 2 places to the left. We always go left. So this becomes 0.0425 times 10 to the fifth plus 6.14 times 10 to the fifth. Now, because we have like exponents now, we're ready to actually do the addition. So what we're going to do in scientific notation is we are going to take the two numbers in front and we're going to add those. So this is probably when you'll want to have a calculator out. So if I take 0.0425 plus 6.14, I get 6.2825, and then times 10 to the fifth. You don't do anything to the exponents. All we do is change the number in front after we have the same exponents. Now, in your homework tonight, I also gave the directions that I want the answers in scientific and standard notation. So in this particular answer, so the scientific notation is 6.2825 times 10 to the fifth. In standard notation, that would be 62825. And how did I get that? I moved the decimal after the 6, and I went 5 places to the right. 1, 2, 3, 4, 5. So my standard notation is 628,250. Remember, on your homework tonight, you have to give both answers, scientific and standard notation. All right, here's problem number 2. I'd like you to stop the video, work the problem out by yourself, and then once you've completed the problem, I want you to come back and make sure you and I have the same answer. All right, so the first thing you should have done was, you know that you have to go to the higher power. So the higher power is 10 to the 9th. So my first parentheses, that number is going to stay the same because that is my highest power. On my second number, 7.18, to go from 10 to the 6th to 10 to the 9th, I have to move 3 times, and I always go left, so 1, 2, 3. So my second parentheses are going to become 0.00718 times 10 to the 9th. So that's what you should have changed first. Now, once you've done that, you should have taken the first number and the second number and added them. So you should have taken 3.65 plus 0.00718. When I did that addition, I came up with 3.65718, and then times 10 to the 9th. So that's your answer in scientific notation. In standard notation, I'm going to move the decimal 9 places to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 3.65718. And then I need to add 4 zeros. 1, 2, 3, 4. So this number is, it looks like 3,657,180,000. Okay? Now we're ready to do subtracting in scientific notation. Process is very similar, except for we're going to subtract now. So the first thing we're going to do is we're going to go to the highest power. So my first number is going to stay the same, 9.456 times 10 to the 7th, minus, now the second number I need to take it to 10 to the 7th, so 5 to 7 is 2. So I'm going to move my decimal 2 places to the left, again, always to the left. So we get 0.0525 times 10 to the 7th. All right, so now we've got the same exponents. Next thing we're going to do is we're going to take the two numbers in front, 9.456, and we're going to subtract now, minus 0.0525. When I do that on the calculator, I came up with 9.4035, and then times 10 to the 7th. And again, the power stays the same once you've gone to the highest power. Okay, just like in addition, I'm also going to make you, in your homework tonight, I'm going to have you move your answer to also standard notation so that you have 2 answers on every problem. So if I go to standard notation, I'm going to go 7 places to the right, 1, 2, 3, 4, 5, 6, 7. So we get 94035, and I need to add 1, 2, 3 zeros. So it looks like I have 94,035,000. All right, so here's example number 2. I would like you to pause the video, work it out, make sure you get it done before you come back and see what I got so that we can make sure you understand this. All right, so the first thing, we need to go to the highest power. The highest power is 6 this time. So my first number is going to stay the same. And my second number, going from 10 to the 5th to 10 to the 6th, I need to move my decimal 1 places to the left. So I get 0.314 times 10 to the 6th. Okay, now I'm going to take my numbers out front, and I'm going to take 6.24 minus 0.314. When I did that on the calculator, I came up with 5.926, and then times 10 to the 6th. And then to go to standard notation, I'm going to go 6 places to the right. So that would be 1, 2, 3, 4, 5, 6. Add some zeros in. So in standard notation, I have 5,926,000. Okay, one last example, number 3. There's a reason why we're doing this last one, and we're going to do it together, because I know this comes up on your homework tonight, so I want to make sure you understand what happens. All right, so here's the problem. All right, so we need to move to the highest power. The highest power is 7, so I need to go 4 places to the left. So in 8.16, if I go 4 places to the left, 1, 2, 3, 4, this gives me 0.000816 times 10 to the 7th power minus 5.29 times 10 to the 7th power. Okay, so here's why I had you do this problem as an example. If I take 0.000816 and I subtract 5.29, when I do that on the calculator, you actually get a negative number, which is perfectly fine. So the answer is negative 5.289184, it's a big number, times 10 to the 7th power. And you just have to make sure you have the negative on the front of it because we were taking a smaller number minus a bigger number. We also have to move this to standard notation. So when I take this number and I go 7 places to the right, I would have 5289184. That's 6 places. 1, 2, 3, 4, 5, 6. I need to go 1 more. So I only have to add 1 number. But the one thing I need to make sure I do, or 1 0 that is, I need to make sure my answer is negative. So it's negative 528,91840. So negative 52,891,840. Okay, now that completes your notes. What you need to do now is show your substitute teacher that you've actually completed the guided notes. She will give you the homework, and you're going to do both sides of the homework tonight. One side is on scientific notation, the other side is on exponents. Have a good day. I'll see you tomorrow, and I'll be ready to answer some questions if you have any. Have a great night.